Yes, no worries, but we'll edit it so that we can cut out the first 10 minutes and just have the session start when Petra starts to introduce the sessions.
Got it.
So you will cut it later on.
Yes, exactly.
Yeah, okay.
Yes. Nobody has access to the stream now except me. I will cut and re-edit it later, and we'll re-upload it later for people to watch on the stream afterwards. So we'll edit it.
Okay, perfect. Hui, you promised me a list of.
Yes,
Yeah.
definitely. I will try to get that to you because I still ask Alonso from Bocconi. He hasn't answered yet back. So if he has an answer later today, then I'll just send you the list right now so that we'll have everyone who has responded that they're still interested in being a part of this.
Oh, okay, perfect. And then I can ask for other candidates. And I already know a person from Bocconi who would like to step in.
Okay, that'd be perfect. Thank you. Yes. So I have to leave soon. Yeah, I leave the hosting to you, Petra, and then you can just let everyone in and then just end the sessions later. Thank you so much, Anita, figure it out.
Thank you very much.
Top series. Yeah, hope everything goes well. I'll also send out another reminders for everyone so that they can start to join in a bit.
Okay, perfect.
Bye-bye. The fact that it's recorded, this live stream thing.
I had a Zoom call this morning and there is new options, like there is AI assistant. Did you see that?
No.
And then you can get automated minutes and something else. Let me see.
And also automatic subtitles or something.
Yeah, with the subtitles, but this is like, what is it?
Like
What?
show captions.
No, but there was something else. Where was it?
Can I try this? Okay. Is this saying brighten what I see?
Who can see this transcript? A participant has enabled closed captioning. So I talk and it writes?
Yeah, you see? Do you read?
No, because you just turn it on for yourself.
Ah, okay. So it's who can see the transcript? Okay, so it's showing only to me. Okay. Well, I will turn it off anyway.
Oh, that would be very useful when talking to a French person.
Well, depends if the
if the system can decipher. Oh, yeah, of course. I'm being recorded and I always...
Yeah. I have actually a question about the talk. So I normally so you introduce myself, so you introduce me, so then do speakers normally tell a little bit about their background and career or not? They jump right into the...
I have prepared the thing.
Okay, perfect. Okay.
I have a suggestion for your description on your CEU site. You cannot say that you spent your time at United Nations. You invested your time. Or worked for. I would rephrase that thing. I was just reading it. So I will tell that you work here, that you have a background in physics and a PhD in applied mathematics. After I'm not sure if I should say that you completed the postdoc, but then worked for 4 years at the United Nations, at this office and the other program. And
now you can skip the postdoc.
Yeah, so I don't have it in the notes, but I was kind of, yeah. And her research explores how complexity and data science can help us address the needs of the most vulnerable populations and monitor the United Nations Sustainable Development Goals. Today, she will first provide an overview of the main application areas where non-traditional data and computational approaches have shown their potential for social impact. Now that I read it out loud, it sounds a bit weird. Like, things that are good when you read it from themselves, but when you talk, this kind of pretend to talk, sentences are too long. And she will then focus on her own work on predicting food insecurity from conflict, weather, and economic data. Maybe from whatever, non-traditional data.
Yeah.
I will, and let you do the details.
Or you can also just keep it, just predict, yeah. You can also stop at
Food insecurity. Yeah, you see? Shortening sentences. She will first provide an overview of the main application areas where non-traditional data and computational approaches have shown their potential. This is things that are good only when they're written. Where non-traditional data and computational approaches are used. No. Have shown potential. Are applied. No. Approaches applied. Data computation. I'm overdoing
it. She will first show some successful applications of these methods for social impact, and then deep dive into her work into food insecurity. Or you can, I mean,
or I can just keep it on together and let you talk. It sounds a bit more fancy, you know, if you got like this our esteemed professor. You always set up your office in a way that you have this white background. With
I don't like
elegant.
it either. I don't like it either, but then I don't like to have things in my back. Like it would be just for the Zoom meetings, but otherwise, like, you know, like.
That was good.
No, I mean,
very professional.
Maybe I should put your painting here or something, so I have a bit more color. Yes.
This looks very professional.
Okay. I'm glad.
I did one painting, but it's now on one of our walls with the turquoise thing. And I went to buy, what is it? Did they run out of blue?
Yeah, you told me they ran out.
But I did some before, and we kind of got used to it. I was uncertain if that would be your kind of painting.
No, but I now I was referring to the one that I already have. But yes.
Oh, what do you have already? What? Ah, the circle one. Ah.
Here.
No.
No.
If you get one for that wall, it should be like not too high, but very long. And
I like the whole width.
No, but it's very good as it is.
Okay. Oh, wow, 18 people in the waiting.
How many?
18. 16 in the waiting.
That's not that many.
No, good. But I'm fine if they don't become more. Yeah, it's yeah, also people normally, I guess, they don't arrive that much earlier.
2 minutes. Whoever arrives 2 minutes early on a Zoom meeting.
Right, no one, right? Yeah, indeed. So it's 16 people that arrived early.
Because sometimes it happens that they put you in the waiting room and you can do other stuff as well. And sometimes you join in, and then even though you were supposed to still do some little stuff and get ready, people start talking to you. And then when you try to connect just in time, Zoom says updating.
Yes. It updates every 3 days or something.
But always when you try to connect in the last minute and you are actually have to be there.
Of course. Okay, it's 4.
I will give it another 15 seconds.
But so people go in the waiting room. This means that then you have, like, for the first 5 minutes, you have to stay there and check if there are people in the waiting room and admit them in case.
I think so. So we can, and when will you start sharing? When I finish introducing you? I
I guess so. Or shall I already put the first? I mean, it's so quick that we can do that.
I need to suck. And then I also need to find the chat because I have to paste something as I talk. Oh, I will just press enter. Ready? No, 26, you see?
Yeah.
What is the admit all? 27 people view. Admit all. Already? Hello, welcome to the CIVICA Data Science Seminar. We will wait another minute for everybody's sound and everybody to connect. I see people are still joining, and we will start in a minute. Okay, my Zoom says that everybody's sound has connected, and I will just start. So welcome everybody. My name is Petra Kralj-Novak. I'm assistant professor at the Department of Network and Data Science at Central European University. I will be your host today for this third of this season CIVICA Data Science Seminar. I have to tell you that this session is recorded. You are welcome to ask questions either in the chat or at the end of Elisa's talk. We will have the opportunity to discuss. What is CIVICA? CIVICA is an alliance of 10 leading European higher education institutions in the social sciences. The CIVICA Data Science Seminar Series is a multidisciplinary seminar series focusing on applications and methodologies of data science for the social, political, and economic world. It is a bi-weekly event that takes place since spring 2021 during the normal term at the universities. If you are not yet, I'm putting in the chat the link where you can subscribe to the seminar series. A few words about our speaker today. Elisa Omodei is assistant professor at the Department of Network and Data Science at Central European University. Her background is in physics with a PhD in applied mathematics. She worked for over 4 years at the United Nations, first at the UNICEF's Office of Innovation in New York, and then at the United Nations World Food Programme in Rome. Her research explores how complexity and data science can help us address the needs of the most vulnerable populations and monitor the United Nations Sustainable Development Goals. Today, she will first provide an overview of successful applications of these approaches. She will then focus on her own work on predicting food insecurity. So, Elisa, the floor is yours. Please share your screen. The talk will be of about 40 minutes, and we will have the opportunity to discuss later on. I see your slides, and you're all ready to go.
Great. Thank you very much, Petra, for the nice introduction, and also to the whole CIVICA community for having me today, and also for being here, to all the members of our audience. Yes, so, well, Petra already introduced me, so let me just dive into it. Okay, so the the broad context of this talk is the realization in the last 10, 15 years that a lot of the data that we nowadays produce continuously whenever we browse the internet, whenever we use our phones, our devices in general, when we use social media, etc. So all of this data can actually be used beyond its original purpose. Like we are generating a large amount of data that can be used also in other contexts than the one it was originally created for. And this also applies to all the satellite imagery and Earth observation imagery that is being captured nowadays. So this data can also be used basically as a proxy of socioeconomic phenomena, socioeconomic indicators. And these are indicators that traditionally, are being measured through household surveys, census data, public and private registries, polls surveys, etc. And the idea of the talk today and in general, like of this line of work, is that we can actually do this also in faster and cheaper ways by using this digital trace data that we are producing anyhow. So this has been applied in a variety of contexts, including the context of the Sustainable Development Goals. And I will start with a few examples, and then, as Petra said, I would deep dive into food security specifically. So a first example, maybe the first application of this has been mapping poverty using mobile phone data and then also satellite data. So the basic idea was to find ways to obtain wealth, estimations of wealth at a relatively high geographical resolution. So this is normally done through census, but in many countries, this is not like something that is done on a continuous basis or very frequently, because it costs a lot, but in human terms and like monetary terms, to run this large scale surveys basically. And so some researchers have started to try to find ways to do this, to find proxies basically for this for indicators. And one of the first papers addressing this was this seminal science paper by Blumenstock and collaborators back in 2015, where they used mobile phone records, so metadata from the use of mobile phones. So every time we make a phone call or we send or receive a text message, our phone connects to the closest antenna, and our mobile phone companies, they record this information for billing purposes or in any case for their internal purposes. And what these researchers showed is that this data can be used beyond just billing purposes, but actually to create such maps. And so what they did was so they worked specifically in Rwanda, in Sub-Saharan Africa and Central Africa. And what they did was, okay, for like a subset of like around 1,000 people, they had access to anonymized mobile phone data. So basically the logs of the calls and texts they made and received and where they were when this happened. And also they called these people and they surveyed about basically in order to get an idea of what their wealth was. Okay, so for this subset of people, they had both their an indication of what their wealth was, plus all this metadata. And then what they did was that they trained a machine learning model to try to infer the wealth of each person from their mobile phone metadata. So they built a series of features, so the volume of calls, how much they moved, if they were calling locally or internationally, etc. And they trained a machine learning model that could predict the wealth of the person starting from this information. So they validated and tested the model on this set of 1,000 people approximately, and then they then ran the model on the whole mobile phone user population of Rwanda to create this kind of maps. Another approach that was instead published a year later used again on science, but by a different group. They used instead satellite imagery to do something like to reach a similar goal. And so the idea again was to try to create high resolution maps of wealth or of poverty levels. And they combined nightlight imagery, so images. So this would be the middle band that you see on the right image. So basically, images where you have like a white pixel if there is light during the night, and they use this in combination with daytime images and some more advanced machine learning techniques to basically again infer from, like, of course, they started from places for which they had some ground truth data of what the wealth level was, and they were able to train models that from these images can infer the wealth status of the area. And then these were like really the first works, and since then in the last 15, now almost 20 years, this has been done using all possible types of data. Nowadays, like people have tried to use Twitter data, to use Facebook data, even Wikipedia data, etc. So really, there is a variety of studies that have been published, where the goal was to try to predict socioeconomic indicators and wealth specifically from all these digital traces that we have at hand. And why is this important? Again, because it can allow us to make such inferences when we need this information, but we don't have fresh ground truth data from census, or like, when a country doesn't have the resources to do so through a census campaign, then they can get a proxy of the wealth of their country, for example, using this kind of method. So it's a way to get a faster and cheaper way to obtain such information from data that we generate anyway already. Another kind of application has been to look into gender inequalities. So, for example, a group of researchers led by David Garcia were looking at online activities and differences between males and females, and they tried basically to characterize geographical differences. So for each country, trying to see whether males or like whether there was a good balance between males and females on the internet. They find so they created this metric of Facebook gender divide, and on this map, for example, you can see that those countries that are more on the red side of things of the spectrum, these are countries where there is a higher divide. So you have more males on Facebook like active online than females, and the blue ones is where there's more of a balance. And the idea here is that by identifying, like, this is important because online connectivity also is a proxy for access to information and how people can like how much of a country, basically like a country where males and females have both access to equal access to online resources, and such as like where Facebook is just a proxy for it. But I mean, this can give you a proxy of gender balance in general, and how much, for example, young female can get connectivity and information to benefit their education and their opportunities, right? Other studies, like for example, the one in the bottom figure, they have looked at mobility traces of men and women using, again, mobile phone data, as we discussed before. So this here, for example, these maps are Santiago, the capital of Chile, and they looked at patterns of mobility by gender. And what they found, for example, is that female, they tend to move less in general, like to do fewer trips and in more in more concentrated areas than men, who move more and more broadly around the city, and that And what they found is that this correlates also with socioeconomic, the socioeconomic status of people. So basically, for example, the fact of having public transport near you doesn't really improve females' mobility, because in a city like this one, where there are high level of criminal activity, and like women are not very safe if they travel on their own. So for example, having access to public transport doesn't really improve, doesn't really affect their chances of moving more, etc., because they might still, like if they're not wealthy enough to be able to move by with private car, etc., they might still not move because of safety issues, for example. And you can make all these kind of observations about this mobility pattern by using indeed this sort of data. Other things that have been explored are, for example, migrant integration in cities, also through Twitter data or mobile phone data. But let me now deep dive already into the Sustainable Development Goal number 2, which is the one that I basically worked on the most through my work at the World Food Programme, and then even nowadays I continue working on this in my research back in the academic setting, and the idea here is to use this kind of methods, this kind of data to study food insecurity, food security. So let's start just by defining what we're talking about. So in general, we say that food security in a given area exists when all the people there at all times have physical and economic access to sufficient, safe, and nutritious food. So it's about the food being available and also being accessed by the people. And this is like a severe issue around the world. So in one of the latest estimates reported that there were, like back in 2021, there were almost 200 million people that are acutely food insecure. And this is across more than 50 countries and territories around the world. And so as you can see, broadly, like of course, like the bulk is in sub-Saharan Africa, but we also have this issue in Latin America, in Asia, and unfortunately now even closer to us, for example, well, to us, sorry, to me as I live in Vienna, like in, for example, unfortunately, since the start of the war in Ukraine. And what this phenomenon, like at some point, it seemed like until 2018 that it was sort of stabilizing or things were getting better, but then unfortunately also with the arrival of the COVID-19 pandemic and other socioeconomic crises, like this basically the situation became worse and worse. And so like nowadays, this is a problem that is affecting even more people. And it is a complex phenomenon. Basically, the main three drivers that experts identifying as the leading causes of food insecurity are, on the one hand, the main one, which has always been basically conflict, so wars, civil conflict, etc. The second one is economic shocks, and the third one is weather extremes, which is gaining more and more space, unfortunately, nowadays, also due to climate change, so droughts, floods, etc. And so, although, I mean, normally, like there is a classification of food security, like each country, like you can identify the main driver, but really most food crises are the result of multiple drivers. So it's a complex phenomenon that that is caused by all of this, like one or more of these So how do we measure food insecurity? There are a variety of indicators that have been developed during the years to go about this. So there are some of them. They look at the diversity of the dietary intake of people, of households. Some others look at the consequences of constrained access to food. So different indicators have shown to provide sort of similar information in this sense. And so what I used in my work is one indicator for each of these dimensions, so the food consumption score on the one end and the reduced coping strategy index on the other end. What is the food consumption score? So these are all household level scores that are obtained through survey, by surveying the households. And so what people are being asked is, in the last 7 days, how often did you eat food from different food items? So for example, how often did you eat staples? How often did you eat fruit? How often did you eat vegetables, etc.? Normally these surveys are done in the local languages. They provide examples for each food group. And then these frequencies are weighted, are summed together in a weighted manner where more nutritious food are weighted more. And this weighted sum basically forms the so-called food consumption score. So the higher the score, basically the more acceptable the food consumption of the household is. If the score is below a given threshold, we say that the household has a poor food consumption. If it's between like 21 and 35, we say that they have a borderline food consumption. If it's above 35, normally say, okay, this household has an acceptable food consumption. So everyone who is in a poor or borderline is considered food insecure. Then we have the second index that I mentioned is the reduced coping strategy index. And this looks at the consequences of constrained access to food. So the question there is, in the last 7 days, how often did you have to rely on the following coping strategies? So people are asked about having to borrow food from family or relatives, having to limit portions at meal times, or, for example, restrict adults' portion to let children eat, etc. And all of these have different severity weights. And so these are also then summed up. These frequencies are summed up in a weighted manner. And in this case, actually, we have that. So before, with the food consumption score, well, the more food you consume, of course, the better your situation is. In this case, the higher your RCSI, the worse your situation is, because like it means that you have to add basically come up with more coping strategies or more frequently. So how is this data collected? Well, UN agencies, local governments, World Bank, etc., like all these organizations, they perform data collection through several modalities. Traditionally, this has always been done face-to-face since, let's say, now 8 years, more or less. This is done increasingly through mobile phone calls. So it could be SMS or interactive voice response, but mostly it's really just live calls from call centers where people are asked about their status. And the World Food Programme specifically has set up this near real-time food security monitoring system. So they basically run these household surveys on a daily basis in over 30 countries through this computer-assisted telephone interview. So they try to monitor the situation in as many countries as possible, as frequently as possible. And so once you have like this household level information, then what you do is that, like, you run these surveys, you try to get a representative number of people from each region that you're interested in, and then you aggregate this information to obtain like an estimation for a given area. So far I've spoken about household level indicators, and now the unit of analysis that I will have moving forward is at the first level administrative units. So basically the first subnational level that you have. So in each area at subnational level, you can look at the prevalence of households in your survey that have been classified as having poor or borderline food consumption according to the food consumption score. And so this gives you the prevalence of people that have insufficient food consumption. So this will be our first indicator of food insecurity for that area. And the second indicator is the prevalence of households that have a reduced coping strategy index that is greater or equal to 19. And so these are this is the prevalence of people that are using food-based coping strategies at a crisis level or above crisis level. So these are the two indicators that we are interested in, and then we want to try to estimate using secondary information whenever this information is not available firsthand. So this is our basically first research question. So indeed, like these organizations, they are trying to collect as much data as possible on a continuous basis. But of course, as we mentioned earlier, this is a very costly effort, right? So we are, it costs a lot of money, it costs a lot of time. And so unfortunately, you cannot always cover all the areas that you would like to cover at all times. And so the question here is, okay, since we have all this historical data and we have other information about the drivers of food insecurity, can we actually use this other information to make estimates of what the security situation is in a given area at a given time, whenever we don't have this first-hand basically information on food security. So how did we go about that? Again, we started from the main drivers of food insecurities, the one that I mentioned earlier. So the idea, okay, I want to predict a phenomenon. How do I want to estimate the extent of a phenomenon? How can I do that if I don't have information on the phenomenon itself? Well, I look at its drivers. And so we collected data about the main drivers in order to train a machine learning model that from those could estimate the food security levels. So for conflict, we resorted to ACLED dataset. Basically, ACLED, it's a project that collects conflict information on a weekly basis. It is updated, but it's like daily information from news, online news. From that, it's a combination of manual and automatic extraction from these texts, and so you have daily information with latitude, longitude information, or subnational level information of where conflict events are happening and how many people die, etc. So this is our first data source. For what concerns economic shocks and economic indicators, we use some more traditional macroeconomic indicators from trading economics and undernourishment baseline figures from FIO. And then we use market prices of local market food prices that is also being collected by WFP on a continuous basis. And then finally, for weather, we resort to satellite imagery, and so specifically to CHIRPS and to MODIS that provide every 10 days an estimation of how much it rained. And this is like worldwide images that then you can aggregate at different levels. So how much it rained, what is the status of the vegetation, and more importantly, this has historical data now for tens of years. And so you can also calculate anomalies with respect to the historical times. And so the idea is it raining more or less than usual in this area at this specific period of time, or is the vegetation like greener or more brown than usual than it should be, or than it has historically been in this area at this time of the year? So we built this data lake with all of this information. These are all data sets for which there is historical data, but also that are being updated frequently. So we need we only restrict ourselves to data sources that are basically being consistently updated, because we wanted to create a model that can then, an algorithm that can run in near real time moving forward. So it has to be something sustainable. So from all of this, we built a series of features, and we associated this. So for each area at a time period for which we had a measurement of food insecurity, like one of the indicators that I mentioned earlier. Then for those, for each area, we associate this vector of feature that looks, again, conflict, weather, and economic situation in the same area at that time, or at the time, like the 3 months before that time. And so this is what what we use. So our training data in terms of ground truth, as I mentioned, so we have different algorithms for the 2 different indicators, and we have luckily tens of thousands of observations for both that were collected in the past 15 years that we can use to train and validate our model. In terms of modeling approach, we used XGBoost implementation of the gradient boosted decision tree ensemble. So machine learning techniques based on decision trees. And what we have is that we have 4 models. So 2 for each, so 4 algorithms, so 4 fitted models, 1 for each, 2 for each of the indicators. So for the prevalence of people with insufficient food consumption, for example, we have 2 kind of models. So in one case, so for some places, we also have like sort of a recent estimate of the indicator, like so some data was collected, let's say, I don't know, 6 months ago. And so we use this information to inform our current estimation of the indicator. But then this is not always available. For other places, we only have older data. And so what we do is that we also train a model where this variable is not included. So the second model only relies on secondary information. And we do the same for the other indicator. And actually, for each of these, we do like we create n 100 bootstrap versions of the model, so that in the end we want to get something where we have like that our prediction is given by the median of these 100 predictions, and so we can also get a 95 confidence interval of where basically of the a confidence interval on the actual, so that we don't give, of course, like just a 1 point estimation, which would not be realistic, but we give basically like a minimum and a maximum value, like a fork, let's say, that to provide to our colleagues at the World Food Program and the other organizations to as an estimation of where the what the food security status is. Okay, so the results, basically, we obtained. So these are the coefficient of determination and on the test set and the mean absolute error. And as I mentioned, so we have the food consumption indicator and food-based coping indicator. In general, our model performs better for food consumption because indeed this is an indicator that was introduced earlier and more widely used. So we have data, we have more data points, but also that are for more countries, like more areas and longer in time. So it's a richer data set, and indeed we see this also in the results. So we are able to train the model with a higher variety of data. And what we find, of course, again, not surprisingly, if we include like a previous assessment, like a recent assessment as one of our input data, we perform better than just looking at the secondary information, as one might expect. But however, we also, just as a sanity check, we also trained a model. The one that is here is called naive model, where we use only the previous information. And indeed, of course, like just by looking at the previous information, I mean, we still get an R-squared that is relatively robust because, of course, things change, but they cannot change like most times. Well, they can change dramatically, but most times like this will already give you like a signal for what you expect to get, for example, 6 months later. However, this score is much lower than what you obtain when you include also the information about the drivers, so climate, conflict, and economic information. So meaning that indeed you can have a baseline from the last available data point if measured recently enough. However, this secondary information really helps you to get a better estimation of the current situation, because food security is indeed a dynamic, like a quite fast changing phenomenon, and so like it's important to include fresh data on its driver to get the best possible prediction. One thing that we did, besides looking at the goodness of the fit, the goodness of the model, it was important for us to explain this prediction and the changes in trends that we would get by running the algorithm on a regular basis. Because of course the goal of this algorithm was to inform decision makers at the World Food Programme and other organizations. So it was important for them to get a sense of why we get the numbers that we get, right? And so we used a SHAP values approach to this. And the important thing for us, rather than explain the individual prediction, was that so basically the model now is deployed on a platform, and it runs on a daily basis. So every night, basically, the data lake gets updated. So all these input variables that I told you about, the sources are queried, and if there is new data, it comes in, and then the model runs. So you see these trends that I show you on the top. Of course, like they're quite flat because many of our input variables, of course, they don't change on a daily basis. But whenever there is a change, the model basically, well, there is a change that has a significant impact, then the model, you see that the prediction can go up or down, etc. And so what was important for the people that had to use this model was to understand why the model predicts, for example, a change in prevalence from 10 to 15% at the beginning of September, just in this example. And so through SHAP values differences, we were able to show what are the basically the features that played the biggest role, anytime there is a change. So we then show also the value of these features before and after the data point, and also the relative importance in the prediction. Finally, as I mentioned, this model was operationalized, and it's now you can access the results of it on the Hunger Map live website, which is an open website that anyone can browse. And basically, whenever you select a country there, you get so depending on the country, so if it's a country like Yemen or Syria where there is an ongoing data collection with the data being collected on a daily basis, then the trends that you see there, they come from this data collection. But for other countries where this data collection is not ongoing on a continuous basis, then you will see that the values that you see there, they come from basically this algorithm that is, as I mentioned, is running on a daily basis in the backend. Good. So this is, of course, there were like a lot of limitations in what we did. So we had to come up with a global model. So the idea, of course, so we basically, since we needed to provide these estimations for various countries around the world, also those for which we had little data, what we did was to basically just train a global model, putting all this information together. Of course, this has its limitation. You could have basically more, like for countries where you have a lot of data, you could potentially train and validate local models like for specific countries. But of course, this was not our goal because basically places where we have a lot of data are also places where the data is continuously being collected. And so not really the places where we need to perform these predictions, basically. So it was not the countries of most interest. And so we had to use this approach then this included also the fact that we needed to account for unequal geographical representation of different countries in the data. So we had to do some actually subsampling. Of course, since this is a global model, we have less sensitivity to local patterns that you could get with some more country-specific models. And of course, we have data points from very many different countries, but if you want to apply the model to other countries that are not in the training set, of course, this should be done with care, and transferability is not guaranteed. Another limitation was in the type of variables that we could include. As I mentioned earlier, basically we needed to have data that was openly available, it was both historical, but also being updated, and also that had a subnational geographical resolution, and also a temporal resolution that was at least monthly or something like that. And then, of course, all these predictions, estimations that we make, they're not meant for to be taken as a trigger to trigger automatic decision making, but just as sort of a tool and extra information that decision makers can have in order to get a better picture of the global situation of food security, and to compare that also with some other data and data for other countries, just to get a sense of how the situation is evolving. But then, of course, whenever the model provides shows that things are getting worse, then the idea is that this should trigger some more ad hoc data collection on the ground to figure out whether what is actually going on. So these are, I'm almost done. I just wanted to mention that then we also had some follow-up work. So as I mentioned, for some countries like Yemen and Syria, we do have very good data, data at a high resolution, in the sense that we collected, the World Food Programme is collecting this data for years now. So we have this time series. And so here the idea is, okay, here we don't need to make estimation of the current situation because we have the data, but can we actually forecast its evolution into the near future? What we did here was to basically, we tried a machine learning approach based on the time series itself, plus some secondary information, secondary data, like the ones that I already introduced. And where we're at right now is that we can make reasonable forecasts up to 30 days into the future, which is, I think, already an interesting first step. But then at the same time, more work is required here, because if you want to use this information, like these models, for any sort of actual action, like decision making, you need basically to know things more in advance. So ideally, we would need a forecast up to 3 or 6 months into advance, and for that, much further work is required. In a follow-up work, we also looked a little bit more into the role of conflict and how we can actually use the ACLED data better by identifying conflict that is related to the food system and the food chain. And by doing so, we were actually able to better predict food insecurity levels. These are my collaborators. So of course, this is not something that I did on my own. So I work with, mostly my colleagues at the World Food Programme, but then the last two works that I mentioned, they were done also in collaboration with the ISI Foundation in Turin, and then and with colleagues at the Dublin City University. These are basically what the bulk of what I present today is in the first is in our Nature Food paper from last year, and then the two other papers were just recently published this year. So you can look into this if you want to know a bit more. Also, just going back to the broader picture, if you're interested in general in how complexity data science, but more broadly complexity science and non-traditional data sources can be used for social impact, for the SDGs. I also recommend this perspective piece that I published with some colleagues last year. And finally, also, I would like to advertise a call for papers that we have right now in the journal Advances in Complex Systems, so the topical issue on complex systems for social good that I'm guest editing with some colleagues that are also some of my co-authors. And so if you think you have a paper or something potentially relevant for this special issue, please don't hesitate to reach out. The deadline is December 15th. And thank you very much for your attention.
Thank you, Elisa. It was very nice, very informative, and a nice overview. We already have a question in the chat. Somebody asking if your slides might be made available after this talk.
Sure, no problem from my side. I will share them with the organizers.
Okay. The session is also being recorded, and the recording will also be available. I saw many people weren't able to join at the beginning, but we have quite a crowd now. You are welcome, everybody, to either ask questions in the chat or you can also unmute yourself and get the opportunity to speak. But
yes,
since I'm chairing, I will just take the opportunity for two very short questions. Your reporting means mean absolute error at some point, the R square. So the correlation coefficient and the mean squared error. No, pardon.
The coefficient of determination, yeah.
So what's the whole range of the value? So it's between 0 and 1?
Yeah.
Okay. So
yeah. So it's that's why we need really that error bar there, because indeed, like we make predictions that are like with an error of like up to 10%. So the idea in general, anyways, that you're more interested to see if things are getting worse or better. So you're mostly interested if they're getting worse, in case you need to intervene. And in general, as you can see also on the younger map, basically we have like, so we like the model gives like a continuous number, like a prevalence that then you can translate into number of people by multiplying by the population. But then like sort of the maps, they are colored according to some large brackets where basically if you're above 40%, then it's like high food insecurity, and then below that you have a few more categories. Yeah, so the idea is what is mostly interesting for the users of this model is to see, like, so as we run the model, to see if things are getting worse or not.
Okay. So I will now give the word to Aaron, who raised her hand.
Yeah.
Yes, it's me.
Okay. We can hear you. Please go ahead.
Hi, Anna, and hi, Elisa. Thank you for your presentation. It's wonderful and useful talk. I am the master's student at Tepe University in Istanbul. My department is political science and international relations. And I wrote a thesis on food security, the case study European Union and Turkey. And here's my questions. Some countries do not share sufficient information about food with the world public. For this reason, it's difficult for researchers to conduct more qualified research using data sets. You mentioned before intelligence data sets. I need a data set or similar data flow on food waste in Turkey and EU. And are there any websites or resources you can recommend to me and the subject?
So I saw a similar question in the chat. I don't know if it was by you or someone else, but I'm gonna put a link here in the chat. So there is this website curated by UN OCHA, so the Office for the Coordination of Humanitarian Affairs. So it's called the Humanitarian Data Exchange, and where they try to really collect all the available data sources in this in the humanitarian and development context. So you can take a look there. To be honest, I'm not an expert at all on food waste specifically, so yeah, I cannot recommend like a specific data source for that, but maybe you can try and have a look there. Also, one thing I would like to mention is that for everything that I showed you today, we have made all the data available on public repositories. The information is, you will find it in the paper, in the data availability statement, but yeah, so people can reuse it, try to reproduce the results, or even better, try to come up with better models so that could be then shared with the Workflow program to improve their platform. So yeah, everything is available for people to do their own research and yeah, and share the results.
Thank you so much. I'm grateful.
Okay, so there is a question in the chat that how can you relate this information on food security to food loss and food waste? I think it was in part already answered, right? Congratulations on the nice talk. People interested in working with you, Elisa, what do you say to them? Send an email. Elisa, it's not really hard to find on the internet. What is the status regarding the sharing of knowledge by the major companies sitting on data troves? I know there are respective programs, but how openly do Facebook, Google et al. Share their data, and how open are they to collaboration?
Yeah. That's yeah, very important question. So as you know, yeah, like it's harder and harder to get data. Like so there basically now most of the APIs have been shut down since 2016. Facebook, so Meta as a program, like for social good, it's mostly focused on natural disasters. So they have this platform where you can register, and yeah, so they share data whenever there is a well, I don't know if whenever, but like in many cases where there's a natural disaster hitting an area. For example, they did it with the earthquake in Turkey and other things like that, floods, droughts, etc. And they provide basic information of activity levels, displacements, like of movements recorded through Facebook during and after the emergency, as well as compared to a baseline period of 3 weeks prior. Google also shared some mobility data during COVID. Like normally, so these big data providers, I think they're like mostly they create some curated data set that they are willing to share with researchers. Sometimes they just put it publicly available. Sometimes you need to have bilateral agreements through your institution. I would say it's not that easy to, like, depending on your research questions and what you need. Normally it's not the case that you just request whatever you want, but there are some data available like that they have created and curated, and so sometimes this can be useful for to address your research question.
Okay, I see Sumath raised her hand. Please.
Hi, Petra. Hi, Elisa. Yeah, it was a great, wonderful session. I have 2 questions. Elisa, you have specified that you have used the XGBoost model, but XGBoost has been, like, nowadays has been the common one. So how much was the accuracy you're able to achieve using this one?
Sorry, I didn't get it.
Yeah,
What is
the
the
XGBoost
accuracy that I was
model.
able to achieve where? Sorry.
Yeah, what was the accuracy levels you were able to achieve and how much it was sustainable?
You mean
It's a regression model, right, Elisa? So there was no accuracy with your model. It was a regression model. With
yeah,
the
exactly. So I reported the goodness of the model in terms of coefficient of determination mostly. So the R square. And so basically in the best scenario, like so I had to remember like 4 models. So the R square varied. So in the best case, we were able to basically to explain 81% of the variance, and in the worst case, around 60-something%.
Okay. The other question is, as we are trying to use data science for solving some problems, it is also creating new problems, such as so now we use data science to solve the food. It is increasing the carbon footprint as we have been so much dependent on the hardware. So what about that factor, that how much of the data science can be used for maintaining the lower factors? And what about the data security? Because when we have a data, it can also be used for wrong in like, because the biasing, it can also be used for wrong purposes. Like how accurate the developers can be in this, right?
Yeah, that's an important question. So regarding your first question, yeah, that's also totally fair. In this case, yeah, these are not like extremely computationally demanding models. So hopefully we're not contributing too much to the issue. But of course, this is something that needs to be taken into account in terms of yeah, like there is this ethical debate, right, going on about whether like sharing these kind of models and data, etc. This can also, of course, always be used not for social good, but for like in principle, potentially also for purposes that that are not good. I mean, I think this is an open discussion, but on the one hand, I think not sharing the data or the models just for this reason, like limits the like basically, well, on the one hand, you're not allowing people to like, you need to ask people to trust your models without them being able to, you know, like reproduce them. I mean, this is a fundamental aspect of science, so I don't think that that would be enough of an excuse not to do so. And also, I mean, in this case, these are very high, like this is all aggregated information, right? So when we do, like we use information for a given area, which, so it's a subnational level, but like the first subdivision you can have in a country. So we're talking about like several square kilometers. And so what we share is information about the food security level, like food security levels there, and then all these other indicators. I mean, in principle, this is not something that you can use to target individuals or so of course there is a like depending on your geographical resolution, you need to be more or less careful. So when you go very like high geographical resolution, then of course you need to start asking more and more of these questions, right? So you need to make sure that whatever you do, whether you publish, cannot allow people to target specific people or populations. But yeah, it's an ethical concern that is also the subject of various discussions in different settings. So yeah, I don't want to give like a definitive answer to it. It's important to ask, of course, these kind of questions.
Thank you.
As always, technology is not evil. The users are sometimes. We have another few minutes and another few questions in the chat. So what is the level of the practitioner into whose decision-making this dashboard can input. So who are the users of this dashboard?
Okay, yeah. Yeah, so basically the main users is the executive board of the World Food Program. So as I mentioned, this is more to allow the people there to have a bigger picture of the situation. So basically every week there is an automatic report that is generated by putting together the data that is collecting through the phone surveys and the estimation that come from the algorithm. And so there is weekly this report that combines the two in order to show globally, like in each country, what was the situation? Is it improving? Is it getting worse, etc.? And then this report is provided to the executive board of the World Food Program that meets every Monday morning, if I'm not wrong. Yeah, as one of the information pieces of information that they get basically for their meeting.
And I think that this also answers Teresa's question. She is wondering, how can this type of data be used operationally on the ground to target assistance to households?
Yeah, so we like the resolution that we currently have, like geographical resolution, like does not allow to go into targeting household level in the ground. So as I mentioned, it's more about giving the big picture, and then on the ground there are people working there that know the situation much better. There is an example, so in a different context, but there is a Nature paper that was published by Blumenstock, so last year, about an application in Togo of how you can do humanitarian assistance targeting through mobile phone metadata and satellite imagery. So if you're interested, so it's not about food security, but just an example of what you're saying. I know maybe we're late, but I can try to find the link before we close the call.
So it is 5 o'clock. So there is congratulations and thank you for you in the other chat messages there. So it's 5 o'clock. It's time to end. I'm posting again the link to the Social Data Science Seminar series for those of you who are connected but don't receive the invitations automatically and updates on this seminar series. Thank you, Elisa, again. This was very insightful, and I think that many people benefited from this talk. I like the description of the whole data science process, from posing the problem, collecting the data, fitting it to the problem estimated reliability down to the dashboard and the use of it. So I really like this complete story, not just a focus on a methodology there. So please mention Indian time next talk if possible. So I guess I saw some people connecting very late, like probably missed the talk by an hour. The talk is being recorded, so also those who missed can have a chance to see it again and maybe contact Elisa directly. So Elisa, thank you again. I will conclude this
Thanks, everyone.
session, and yes, see you around.